Hey dear, how are you all? Welcome back to another video. So in today's video, as you can see on your screens, we are going to discuss about physical classification of matter. Okay, so on the basis of physical properties of matter, how this matter looks like, and how it feels if we touch it. Okay, so on that basis, those are physical properties. We can say color or mass, density, and texture. So on that basis, we can divide matter into three different classes: solid, liquid, and gas. But all these physical properties are decided by the characteristics of the particles of matter. So all these three states are decided by the properties of particles of matter, or we can say characteristics of particles of matter. The first characteristic is interparticle space. That's the space between two particles. And another very important one, that is interparticle force of attraction. These two properties of particles of matter collectively decide the state of a matter. Suppose if we talk about solids, in solids, interparticle space is very less negligible, we can say, and interparticle force of attraction is very high. Okay, and as we go from solid to liquid and liquid to gas, the interparticle space keep on increasing and interparticle force of attraction keep on decreasing. Okay, let's take all these states one by one. Okay, so here we go. Matter can be classified into solids, liquids, and gases. Let's understand the characteristic properties of solid state. Solid state have a definite shape and volume. Since it is rigid, it's hard, it's dense. So it has a definite shape, it has a definite boundary. Suppose I have a pen, or this is a mouse. Okay, so for example, we will take example of this, for instance. So it is having a definite boundary. Okay, so it's not basically flowing anywhere under normal conditions. So it is having definite shape and definite volume. It's incompressible. If you try to compress a solid thing under normal temperature and pressure, so it will not get compressed, so it resists change in its shape. That's it is incompressible. It cannot be its size or its volume cannot be decreased under normal pressure. Coming to third property, it says least interparticle space. Yes, in case of solids, they have very less interparticle space. We can say that particles in solids are very close to each other. Suppose if we take example of a solid thing, and let's change the color so that you get it very easily. Suppose okay, hold on. Okay, so in solids, particles are very close to each other. There's very less interparticle space in case of solids, but it increases in case of liquids, and it further increase in case of gases. Okay, since the particles are very close to each other, you can see they are nearly touching each other. So they are interacting having more interactions, or we can say due to those interactions they are attracting each other. That means they have a high interparticle force of attraction, a strong interparticle force of attraction. Hence, they are rigid. Okay, so this was about the solids. Now let's understand about liquid. So we will understand liquid in comparison to the solid. Okay, here we go. Liquids are indefinite in shape but have a definite volume. Indefinite in shape means, suppose you have liquid in a glass. If you pour this liquid into bottle, it will take the shape of the bottle. If you pour this liquid from bottle into a cup, it will take the shape of a cup itself, but volume will remain same. Okay. Coming to the second property, it's incompressible but can flow. Definitely. Okay. If you take liquid in a syringe and then plug or clog the front end of a syringe and then try to push the piston, so you will barely be able to push the piston inside, isn't it? So that means liquids are incompressible, but they can flow. Okay, so give it a try. Okay, so drop some liquid on the ground and you see it will definitely take its course. So that means liquids flow. On that basis, liquid is a fluid. Liquid is a fluid. Third property, large interparticle space than solids. See, we are just comparing it with solids. So without comparing it with solids in terms of interparticle space and in terms of interparticle force of attraction, so it will not be a clear picture about the extent of the property. So compared to solids, there is a large interparticle space. Since particles are they are not far away, they are not just getting separated altogether, but they are still in touch, but have a little bit space as compared to solids. So having that space will definitely make the interparticle force of attraction become a bit weak as compared to solids. So in liquids, interparticle force of attraction is a bit weak and as compared to solids. So that's why due to these two properties, it's a bit fluidy, we can say. Okay, so it is a bit more, the particles in liquid are more at more ease in terms of space and in terms of force of attraction. So that's why we can easily move our hand or we can easily move any solid thing through liquid, but we cannot move through solids. That's not possible. Coming to the third state of matter, that is, hold on. Coming to the third state of matter, that is gaseous state. Let's understand the characteristic properties. Okay, so gaseous state is the one that is having indefinite shape and indefinite volume. So gases can also take shape of the container in which they are kept, and the volume is also indefinite. A small amount of gas can separate throughout this whole volume of a cylinder, or a huge amount of volume of a gas can be compressed in a small space. That's how it behaves. So due to this nature, it is highly compressible and it exerts huge pressure on the container. So gases can be highly compressible. Okay, so that's why we are able to have LPG cylinders, CNG cylinders, oxygen cylinders for hospitals. So because we can compress this gaseous state of matter in a small volume, and the gas molecules are moving very fast here and there, haphazardly and randomly, and hitting the walls of the container from inside, so creating a pressure called gas pressure. Third, largest interparticle space than solids and liquids. So among all the three states of matter, gases is the one having the largest interparticle space. So that means conversely, it's having the least interparticle force of attraction among all the states of matter. So there is negligible interparticle force of attraction. So the particles are much far away from each other. So there is literally no interaction, we can say. So we can consider there is no interaction between the particles of matter. Okay, but there one thing is there. If we press or if we apply pressure on the gaseous state, particles will start coming closer to each other and develop interparticle force of attraction. That means that will help to change the state of a gas into liquid under high pressure and low temperature. Okay, because if we increase the temperature of any other state of matter, the particles of that state will start flowing here and there, or they will start having higher kinetic energy and vibrations. So ultimately, when they are suppose if we heat a solid, okay, so when its melting point reaches, and it will definitely have very less interaction with its particles, and it will eventually get converted into liquid. If we continue heating the liquid at its boiling point, it will get converted into its vapor state. Okay, but reverse can also be done. If we decrease the temperature of a gas and increase the pressure, it will get converted into liquid. And if we still keep on decreasing the temperature of liquid, it will get converted into solid. Since solid state and liquid state do not get affected by increasing the pressure over them, because pressure doesn't have much significant effect on solid and liquid state. But gases definitely do change their state under varying temperature and pressure. Okay, so this was about today's topic, physical classification of matter. So with this, we reached to the end of this video, and I hope you all are enjoying the videos. So we will be continuing this, and the next topic will be definitely uh, the transformation of matter, how we can change from solid to liquid and liquid to gas, and vice versa. Okay, so till then, keep learning. Bye bye and take care. Do share the videos and do subscribe the channel, and show your love, so that I get motivated to work very hard for all of you, whoever is there watching the videos. Take care. Bye bye.